So we'll be using the Civo Construct SaaS product, which is hosted on Civo. And I think, as mentioned, sovereignty is becoming more important day by day. And also keeping in mind the price point, we would highly recommend using Civo to deploy your workloads. So you can go to the SaaS on the domain construct.saas.construct.io, and you can log in with Civo. And once you do that, you can view all your organizations. And for this demo, I'm using Civo internal services. So for the deployment of a cluster, so as we had already seen the provisioning of cluster in our previous live stream, where you register a Git account, create your cloud accounts, right? So there's already my GitHub repository that is registered. I have already a Civo cloud account that I can use to provision my infrastructure. So we can start provisioning the workload clusters where we can deploy these models. So here I already have a workload cluster, which is a single node B200 GPUs. And so Civo offers a wide variety of GPUs, all the way from L40s, A100s, H100s, B200s, B300s. The list just goes on. You can get more information on the website. But for the demo process, I'll be provisioning workload cluster. So here we just have to select the workload cluster template, which will be just bootstrap, like provisioning the cluster, and also giving the bootstrap materials like Cert Manager, Envoy Gateway, Reloader, to make sure your cluster is production ready. So I'm just going to be selecting a cluster, and for the demo purposes, I'll be selecting my internal cloud account, which using the region. And as you can see, I'm going to be using A100 for the demo purposes, and I will just choose AI dev as the environment. Then for the workload URL, so before, I think I want to mention this again, how do these workload clusters get provisioned? So we follow Terraform-based provisioning. And so whenever you onboard to the platform, I think we already seen a Git account is registered. So when you register a Git account, if you go to that GitHub repository, there should be a folder called Terraform Civo workload cluster folder. Over here, basically all the configuration for the workload cluster exists, all the way from creating that cluster, also bootstrapping it with all the necessary roles and role bindings. The difference is when you provision a GPU cluster, it automatically sees, okay, this is a GPU pool, and let me deploy a GPU operator in that cluster. So that's how it provisions. So I'm just going to be referencing the Terraform that's present here while provisioning my cluster. So yeah, I'll just select cluster. Do you have any opinions? I'll just go.
Let's call it live stream. And then just for our viewers that might not already be deeply familiar with Construct, this is using one of our built-in workload cluster templates that we have upstream. And you might be wondering to yourself, well, maybe I don't want to create a Kubernetes cluster exactly the way that you're creating your Kubernetes cluster. Maybe I have different Terraform opinions. Maybe I have different tools that I want in each one of my workload clusters. And I just wanted to be clear to our viewers that the way that Construct works, we automatically register our upstream cluster templates, but we offer you the space in cluster templates to create your own cluster templates. You can start from ours and just add your tools to it, or you can just create your own from scratch. If you already have infrastructure as code, if you already have a bunch of platform tools that you love, we get that deeply, and we are architected in a way that allows you to plug those opinions about your IAC and your platform tools into the Construct application so that you can deliver your clusters your way still. But we also have some fully operational architectural blueprints, if you will, that we keep upstream that are actually live and usable in all of the various clouds that we support. So when you see Rishi provisioning a GPU cluster here, this is one of our upstream templates that you just get to use for free. But if there were any opinions about the tools that were in this cluster that you needed to be slightly different for your organization, we fully support the ability for you to have your own cluster templates, register them with Construct, and use them as your implementation for your organization. So I just want to make sure that was obvious on the live stream.
Yeah, 100%. So it's very customizable and based completely on what and how your applications are dependent on what tools. So as you see, so we provision that, and this cluster is getting created, but it's gonna be like 2-3 minutes while the cluster comes up. But I want to show the cluster that's already in provision. So for each organization, we will get a Argo CD to manage that organization's infrastructure and workloads. So for internal management, we already have this Argo CD that's given for it, Argo CD - cluster name .sas.construct.io. So here, if I go to clusters, so you see the Hinaus AI cluster is already provisioned. And if you see, there's infrastructure and provider. So we depend on Crossplane. We have a fork version of it. We had made some changes to it. But along with that, we give you Envoy Gateway, Cert Manager, Reloader. And this one you see was the environment that was registered when that cluster was provisioned. So if I show the cluster details page, the environment hosted was AI there. And that's why that extra application is being visible. Good. I think if we go to the live stream as well. So once the infrastructure is up, it should automatically deploy the other applications like Cert Manager, Envoy Gateway, and also the AI dev environment that I had registered to it.
Thank you for that. Yeah, that's a really important detail to make sure we highlight that, like, when you provision clusters using Construct, unlike a lot of our competition, you're not just going to get an empty cluster in your cloud. You're going to get a cluster that's actually usable, valuable, that is ready for your workloads on day zero. So you click that create workload cluster, whether it be a GPU cluster or just a good old fashioned x86 or x64 cluster or whatever it might be. And your clusters will be pre-opinionated with our opinions about what it is that makes those clusters usable, ways to get certs, ways to get domain names, ways to manage your load balancer, ways to manage your volumes and everything. And then you have the ability to change what those opinions are and or just add on top of it. So it makes it a much faster experience. If you're just trying to get that app into a Kubernetes cluster and use it, it's all those prerequisite details that we take care of and make sure that it's super easy and frictionless. So thanks for bringing that up on screen. I appreciate that, Rishi. All those chicken and egg scenarios of getting the infrastructure first and waiting for it, and then getting the next app and waiting for it, and getting the next app and waiting for it, and wiring up all those details so that they all know about each other and everything works. That's kind of the hard part of Kubernetes that we're getting rid of. So
100%. So we have already seen how you can onboard your code or your application onto a Kubernetes cluster. And that's what we covered in the app repositories part. But today we are going to be covering how do you deploy something that's already available in the internet and make it a better experience to deploy on the clusters that you provision. So that's the option that we have. GitOps catalog, we had skipped it last time. Yeah, really got a chance to do this. So before I go, so GitOps catalog is a way for you to register your application that is required to empower your platform. Like if you see here, there is Cert Manager, Envoy, external DNS, all the AI tools, like we have observability, ground cover, the name of, like any application that you think is important to make sure your application is up and running, you can register that as an item and make sure that is deployable to any workload clusters that you provision. So for example, today we are going to be looking at, if I go to Civo internal services. So we are going to be deploying KServe. So KServe is a platform which will help, which will give you that base foundation to deploy models that can be used for inferencing, and the Qwen, which is going to be the model that we will actually deploy. So if we go to deploy the KServe, actually, yeah, let me see if the cluster is already, it's still provisioning. But I would like to, yeah, I'll just walk through it, make sure all these steps are covered. So we just have to get an app release name, then just select the cluster that you. So before that, how these values are populated here. So this is from our upstream templates. So for example, if I just go to the information page on this thing, so the details of this particular item is coming from our upstream templates called Konstruct templates under GitOps catalog KServe on the main branch. So if I go to that particular branch and in that particular path, so you see, so this is a Helm-based engine. So it's just going to be the values from the values.ml in this format that we opinion a bit about, like where you have to provide what type of variable that's going to be the description, whether it's a required field, and it can mean enum as well, and what's going to be the default value that you would like your teams or developers to provision that when they're deploying it. So that's where these fields are coming from. So
yeah, that's a really cool detail to call out too, because like a lot of companies are leaning on technologies like Backstage in order to provide end users with a user interface to provide them a space to give you inputs for the stuff that you need, for the apps that you need, for the infrastructure that you need, for whatever you need. There's always got to be this middleman of being able to paint a form field to present to your users to collect their input and then provide it to your infrastructure as code layer. But with Construct, we've gotten rid of that layer altogether. Parameters are a native feature of our Construct v2 template engine. It's a Helm-based engine. And the way our cluster templates work is identical to the way that our GitOps catalog works. There are templates of YAML, basically. And that YAML has variables in it that you don't know the values to until it's time to provision one of these things. You don't know what the domain's going to be. You don't know what the cloud's going to be. You don't know what region you want it in. Details like that you get to define in your template. And then we have Construct prompt the end user, whether it's during cluster provisioning or during application deployment, whatever those key fields are that are important to get input from the end user, we're able to present that natively in the Construct application to the end user to collect that information and provide those values to the YAML, again, very cloud natively, so that you can have the exchange with the end user responsible for your infrastructure and app delivery without having all of the infrastructure needed to have like a portal. Like there's just no need for a portal if you get cloud native and bake the input parameters into your workload cluster templates and your application spaces. So it's a little bit of a revolutionary stance on how to manage inputs from users. And Construct is positioned in a spot where we have access to all of the information about your cloud and clusters that you don't want to care about. You don't necessarily want to care about keeping a list of all of your cloud regions. You don't want to necessarily keep a list of all of your different instance types for a portal to use to be able to present to an end user. Like you just want the stuff to work. So the way the GitOps catalog and the Construct clusters template, it puts those parameters directly in the administrator's hands so that they can prompt the end user for whatever's appropriate when you're creating these things.
Yes, 100%. So as you see, when we get populated those fields, the ones that are mentioned as, okay, now it's required fields, based on that, the options will be populated. And once we fill the necessary values that you would like to see in your application, we can just go to the provisioning part. So we can see the 2 workload clusters that were provisioned for these organizations are visible. I can select live stream and maybe select the environment as well and deploy. I think the cluster is still provisioning, but I already have KServe deployed on my in-house AI application on the same environment. But you see, I think after the cluster is up, we should be able to see that in that cluster as well. I think it's just syncing up on certain and stuff. But without wasting time, I would like to show the one that's already been deployed, which
Thank
is
you, buddy.
provision cluster. So if you see the first 4 applications, those are the basically KServe CRDs, the operators, the resources that is required, basically the foundation, as I told, to provision the models and inferencing. And KServe does a lot of things, but we will be just checking on to how do you provision a model using that. So after provisioning the KServe, okay, now we have all the necessary things. So let's now go to deploy a model. So for today, we'll be using Qwen model. Again, it's going to be the same pattern. You just have to register it as a catalog application and just follow the same steps of giving the app name, selecting or prefilling all the values. Just show. So you see the same cluster name, the namespace. Then we get a lot of options. Basically, these all are configured in the values.ml, and that's why we are seeing here the model name, storage UI, whether you want to cache it, use PVC, how many GPU you want to give, basically the tensor parallel size, and all the extra stuff. And it's just going to be the same one. I'm not going to deploy this because I think the KServe is not up. But again, we have already deployed that on our pre-provisioned cluster, which is our in-house AI cluster. So if I go to that application, so I had configured to use 8 replicas, and each pod basically getting a single GPU because I have a B200. So if you take a B200 on Civo, you get 8 cards on each node or virtual machine that you provision. And yeah, that's how the model was provisioned. But how do we use this model? Like, how do we confirm that, okay, now you can use it in your day-to-day operations? So I think most of the people today are using some kind of CLI, and I think the famous one is Claude Code. So I would like to show how you can integrate Claude Code with the model that's been deployed and use it as an inferencing. I have deployed this model over a load balancer service type. And let me share my terminal by stopping. Let me know if my terminal is visible.
We got root. We're ready.
Good. So I just have a Docker container with Claude CLI installed, and we just have to export the variable names. I can show. Yeah, Anthropic model, or then yeah, you can use the API as well. We will take the cluster in some time, but if you want to just make sure experience that, or you can sign on to the platform and use it. So if I just start the Claude CLI and just go to like the model that I am on, so you see that we are hooked on to the Qwen model that we just provisioned. So if I just say how doing something like that, right? Maybe I'm bad at prompting, but so this is how you can use this one into your day-to-day like operations that you would like it can do more than how you're doing, basically code reviews, all the documentation stuff, like basically everything that you would experience from the Opus models that you use on the enterprise version. So, but basically this ensures that sovereignty and prices are within your limits and control within your limits. And so this is how you can provision self-hosted AI using Konstruct within minutes. Like, imagine doing this all through kubectl. Like, it could have been done, but again, how do you maintain those 1,000 values 1,000 optimizations? Like, this was just one model. Let's assume in a cluster you want like 3-4 models that you would like to use and use it for different purposes. So Konstruct really helps solve that issue of maintaining the infrastructure and making sure teams and developers are not disturbed and always are up running.